Okay, we are going to discuss graphing and writing function rules. We've got a couple examples for each of these, and this video is going to kind of talk through each one of those. So we're going to start with problem 1.
In this problem, you will graph a function rule. What is the graph of the function rule? Y equals -2 times x plus 1. Step 1. Make a table of values. What input values make sense here? It is possible to use any input x in the equation and get an output y. Choose integer values of x to produce integer values of y, which are easier to graph.
Basically, don't use fractions and decimals unless absolutely necessary.
Write your input values in the table.
And those are just examples.
Substitute each x value in the equation to find each corresponding y value. When x is -1, y equals 3. That gives you the ordered pair, -1, 3. When x is 0, y equals 1. When x is 1, y equals -1.
Just substituting in each one of those values for x.
And when x is 2, y equals -3. Step 2. Graph the ordered pairs. Plot each ordered pair from the table.
Make sure you've drawn your x and y axis there and you've filled it in appropriately and plotted those points, which should be a very simple task.
Now, connect the points with a line to represent all solutions. Now it's your turn.
All right, I want you to try this one. This problem here, I just want you to try to graph it, and I want you to come up with whatever values you want for x. Plug those values in for x, and I would usually use 4 or 5 different values, and then graph it just like that last example. Pause the video, back up, go look at the example again, whatever is necessary. We're going to discuss this in class, so I'm not going to give you the answer, but I do expect you to have something on your paper where you've attempted this problem from the video. So now we're going to move on to the next example.
In this problem, you identify continuous and discrete graphs. A local cheesemaker is making cheddar cheese to sell at a farmer's market. The amount of milk used to make the cheese and the price at which he sells the cheese are shown. Write a function for each situation. Graph each function. Is the graph continuous or discrete?
Now I'm going to bring up the key concepts here about continuous and discrete, and I want you to jot these down and make sure you have these in your notes. A continuous graph, we've talked about this already. We discussed this when we brought in linear and nonlinear functions, and I wanted you to know when to connect the dots and when not to. A continuous graph is a graph that is unbroken. Basically, every number between 1 and 2, okay, all the numbers are going to work. Whereas a discrete graph is composed of distinct points, which just indicates that the values between these points do not make sense in the problem. Okay, so these are the two different types of graphs that we're going to discuss in this problem, so make sure you have those definitions. If necessary, pause the video, make sure you have them written, and then move on.
The weight, W, of cheese in ounces depends on the number of gallons, M, of milk used. So W equals 16 times N.
Now, it's not necessary for you to write every single thing that she says and every single thing that you see on the screen. You've got to write what's going to help you to identify continuous and discrete, write these functions and graph them. So you may just need to know that 1 gallon of milk makes 16 ounces of cheddar cheese. Okay, so the weight of cheese depends on the number of gallons. That's your independent and dependent variables there.
The amount A of money made from selling cheese depends on the number N of wheels sold. So A equals 9 times N.
And they're just simply coming up with these variables from the information. Okay, they're just making up the weight of cheese is W, the gallons of milk is M. So you could use whatever variables you wanted here, but these are two separate problems that we're graphing in one example here. So that's the reason why we've got 4 different variables going on.
First, graph the function that relates the weight of cheese to the number of gallons of milk. Make a table of values. Find the value of W when M equals 0. Then find the value of W when M equals 1, 2, 3, and 4.
Just plug in for M and solve for the weight.
Now graph each ordered pair, M, W.
Notice that they're just in the first quadrant because we're only dealing with positive values.
How can you decide if a graph is continuous or discrete?
Also, real quick, notice that the W, which is your y-axis here, is marked off so that all the values fit. Rather than marking off by 1s or 2s, they've got them marked off so that they can get up to 64 on the y-axis. Okay, so that's something you'll need to also do whenever you're setting up your graph.
Decide what values are reasonable for the independent variable. For example, even if 3 and 4 make sense, 3 and 3/10 and 3 and 7/10 may not make sense. Any amount of milk makes sense, so you can connect the points. The graph is continuous.
Basically, you could use a half a gallon of milk or 1.5 gallons of milk or that sort of thing. That's the reason why we can connect the dots.
Next, graph the function that relates the amount of money made to the number of wheels of cheese sold. Make a table of values. Find the value of A when N equals 0. Then find the value of A when N equals 1, 2, 3, and 4.
Same thing that you did with the milk, you're now doing with the wheels of cheese.
Graph each ordered pair, N, A.
Same sort of graph as last time. Notice that the y-axis, which is your amount of money, is marked off so that all the points will fit. And you're only in the first quadrant because we're only dealing with positive values.
Remember that you can tell if a graph is continuous or discrete by deciding what values are reasonable for the independent variable. The cheesemaker can only sell whole wheels of cheese, so the graph is discrete.
He can't sell a half of a wheel of cheese or 1.5 wheels of cheese. He can only sell whole wheels of cheese, so we cannot connect our dots. Okay, so a good example of continuous and discrete graphs. Now we're going to move on to actually writing functions. Now, writing a function rule is just a little bit different. You're going to have word problems most of the time, and you've got to pick out the important information. So we're going to do one example here, and they really break this down really well on how to estimate or how to write a function rule.
In this problem, you will write a function rule. You can estimate the temperature by counting the number of chirps of the snowy tree cricket. The outdoor temperature is about 40 degrees Fahrenheit, more than 1/4 the number of chirps the cricket makes in 1 minute. What is a function rule that represents this situation? First, relate the information given in the problem. The outdoor temperature is about 40 degrees Fahrenheit more than 1/4 of the number of chirps made in 1 minute. Now define your variables. Let T equal the temperature, and let N equal the number of chirps in 1 minute. How can a model help you visualize a real-world situation? Use a model, like the one below, to represent the relationship that has been described. 1/4 of the chirps per minute and 40 degrees combine to yield the temperature.
That's just a good visual representation of this relationship.
Use the variables you defined to write an equation based on the phrases you related. The temperature, T, equals 40 plus 1/4 times the number of chirps per minute, N.
Basically, you just got to take what you have here written out from that sentence, pulled out the important information from the word problem, defined your variables, and then just put it into a mathematical statement, into a mathematical equation here, knowing what your words like more than, of, is, represents in math.
So a function rule that represents the situation is T equals 40 plus 1/4 times N. Now it's your turn.
Okay, just like the one where I wanted you to graph the function rule, this one I just want you to see if you can write this function rule. I'm not going to give you the answer to this just yet. We are going to discuss this in class, but I just want you to try it. Okay, don't get frustrated. See how far you can get. Do the relate part where you pull out the important information using your words, identify your variables that you're going to use, then actually write your equation based on that you have pulled out. So just give this a chance. Try to come up with something. I'll just be looking to see that you made an attempt on this, and then we'll go from there in class. We'll discuss a lot more with writing and graphing function rules in class.